Um, so, I think in some sense the vertical structure profits is kind of I guess it comes from several answers I'm thinking of at the same time. I'd say the focus on vertical structure profits is kind of for two reasons. One is kind of a theorist's reason of understanding what externalities operate. And so you understand kind of how the contract, in some sense, something about how the contracting process works. The I/O thing, there are some features, like the old Chicago school argument would be like if you have a monopoly at one level, that should, that monopolist should be able to get all of the the industry should be able to be a monopoly. And we see that's true in some cases, not others. So that's kind of a little bit of the I/O interest in that. I think obviously if you're analyzing the effect of a vertical practice or a merger or other things from a policy perspective, you're interested in consumer surplus too. So it's not like, in terms of these theorems, it's, the first two of those. When we actually start doing empirical work, it's typically not you'll measure industry profits, but that's typically not the question you're asking. So, yeah. Okay, so we ended up here. All right, we had this fixed point condition and the necessary condition of maximizing bilateral surplus. So let's kind of have a parallel result to the kind of result we had before. One was under what condition, the first part will be under what conditions we maximize vertical structure profit, joint profit. And the second will be if there are, and that's going to be a result about having no externalities. But in this case, it's going to be what's called no externalities on efficient traders. So the theorem is going to be that if there's a profile X star, which is where X star maximizes joint vertical structure profits, joint profits, and when everyone has their component of X star, so Eric has his XE star, and Ariel has his XA star, and everyone else has their X star. That's part of that. There are no externalities. Okay, that's what I mean by no externalities on efficient traders. And the theorem is going to say when that's true, any passive beliefs equilibrium is efficient. Okay, number one. And then there's going to be a result about what if externalities on efficient traders are positive or negative, and what direction. And we have condition W, so that welfare depends on the aggregate trade. And the result is going to be just the obvious direction you'd expect, which is when we have positive externalities on efficient traders, we get too low an X star. When we have negative, we get too high. So I guess in parallel to what I did before, I'll just show you the argument for for the efficiency result, and I'll leave you to look on the next slide at the direction result if you want.
What is efficient trade?
What is an efficient trade? It's just what I said. So imagine X star is a vector, a profile of trades. Every one of you, which is efficient. Okay? So every one of you has your component of X star, the efficient trade profile. That maximizes the profits of everyone in this room. All of you plus me. Okay? Saying there are no externalities on efficient traders says that when you are having your trade profile, your part of X star, you don't care what everybody else trades. So as long as you're trading your component of the efficient trade profile, you don't care about everybody else. Okay? And in particular, what this is saying is if there is, just since you're Mr. Multiplicity, if there is, sorry, you're not, anyway, whatever. If there are multiple efficient trade profiles, as long as that's true for one of them, then every passive beliefs equilibrium is efficient. Okay, so the result.
So does that mean that every passive believes equilibrium trade will be that?
No.
But if it were some other one, then
No, that's a good. So actually, I think the argument I'm going to give you doesn't show that. I have to think about whether it can be shown. Okay, so the argument is, imagine we have a passive beliefs profile. Then that fixed point condition says that evaluating that expression that we had in the fixed point at xp, the passive beliefs profile, has to have at least as large a joint payoff as if I keep everyone else's trades in this term at their passive beliefs trades, but change to this x star, which has no externality, which is efficient and involves no externalities, at which there are no externalities. Then I know this inequality has to hold by definition, by the necessary and sufficient fixed point condition for a passive beliefs equilibrium. This is just that condition. Okay? And now, saying that at x star there are no externalities on efficient traders at that x star says that I can change this xp to x star. Okay? But then x star is efficient, so what we're saying is the passive beliefs profile has to be efficient. Okay? So it's that simple. Again, I'd have to think a little bit about other possible, whether that pins down uniquely. I still think I think my answer initially is right, that it doesn't. But even if there's a unique, I guess, right, we didn't say in your question whether there was a unique efficient trade profile at which there were no externalities. Implicitly, I'm taking your question to be, is the set of passive beliefs equivalent to that, matching that? So, and then anyway, when you go look at this tonight, this is the second half of the result, just the argument about direction. Okay, but since it's kind of very intuitive, I don't want to take the time right now. Okay. All right, so let's just go a couple of examples of applying this. And we're going to go to our two canonical examples. One is the monopoly retailer example. Okay. So again, the upstream manufacturers have costs C1 of x1, C2 of x2, and C of x. Okay. And downstream monopolist has this additional cost C of x. Consumer demand is x of p. And suppose we do the same thing we did before. We suppose that the retailer offers each manufacturer, in this case, to buy at cost, at C1 of, actually, it could be either, either at point contracts or, another possibility is offer a nonlinear contract that reimburses cost exactly for any x1. In either case, there are no externalities on traders, on efficient traders. And both of those, so let's take this example. What the offers are is I will reimburse, I offer, my contract says I, the retailer, will get to pick how much I trade with you, and I will reimburse you exactly for your costs. Okay? So if both of those contracts are accepted, the retailer faces the true cost of the upstream manufacturers and will pick the right quantities or prices downstream. So these are contracts that do, if they're accepted, they induce efficiency. So they are an example of X star, of a profile X star of contracts that induce efficiency. That's number one. Number two, if you sign a contract that says no matter what trade the retailer does with you, you will be reimbursed for your costs, there are no externalities on you. You don't care how much is traded with you. You earn zero no matter what. Okay? So in that case, when you sign this contract, these contracts induce efficiency, so they're an example of an X star profile. Number one, and I'm speaking of X star here in a generic sense, they're not the literal quantities. What they are, this is a set of contracts that that are efficient when signed, that induce efficiency. And number two, given that you signed that contract, you don't care what happens with the other guys, what contracts the other guys sign. So in that case, the result applies, and we have no externality. We have no externalities on efficient traders, and we know that we're going to get joint efficiency. Okay. All right. Let's think about the Cournot retailer model, and for simplicity, let's just focus on the case where we have point contracts. So Cournot retailer model, we have the upstream manufacturer and two downstream retailers. All right. And imagine that the contracts are, with retailer 1, it's a quantity X1 and a payment T1. With retailer 2, it's a quantity X2 and a payment T2. So that's what I meant by point contracts. It, in fact, generalizes to allow general nonlinear contracts, but let's be more specific just to kind of make clear what happens. So in that case, imagine that X1 hat and X2 hat are equilibrium trades with the two retailers. Okay? The necessary condition that we derived said that as a necessary condition, the contract between each pair has to maximize that pair's joint surplus, joint payoff, given the trades that other pairs are making. Okay? The deals that other parties are signing. So that means that the quantity sold to retailer 1 has to maximize over X1 the joint payoff of the retailer 1 and the manufacturer. Retailer 1's revenue, given that retailer 2 is trading X2 hat, is this. This will be the price given X1. This is the quantity that retailer 1 is buying, X1. Okay, and the total cost of the upstream manufacturer is C times X1 plus X2 hat. Okay? And likewise, a second necessary condition is that X2 hat has to maximize over X2 the retailer 2's gross profit minus the manufacturer's costs, holding fixed X1 hat. Okay, so those are the two necessary conditions. All right, well, first thing is when we maximize with respect to X1 and X2, this X2 hat doesn't matter. It's just additive. And this X1 hat doesn't matter. It's just additive. Okay? And now let's look at those two expressions. Okay, those two expressions are exactly the Cournot duopoly problem. Okay? Imagine that instead of the manufacturer selling to these retailers, each retailer could manufacture for itself at the upstream manufacturer's cost of C per unit. Well, retailer 1 would maximize exactly this expression. Revenue, holding fixed X2 hat, the output of this other retailer, minus cost. And likewise, retailer 2 would maximize its revenue minus its cost, holding fixed X1 hat. So the outcome here is the Cournot duopoly outcome, which is definitely not the joint profit maximizing outcome. The joint profit maximizing outcome is not the Cournot duopoly outcome, but the joint monopoly outcome. Okay? So what you can see here is, in this case, remember back when I started with this Cournot retailer example, I said, well, we have a monopolist upstream, but we have competition at the retail level. Do we get a monopoly outcome for the whole industry, or does that competition at the retail level matter? And what we've seen is it depends on whether the contracting process is public or private in these models. So with public offers, the answer is we get joint efficiency because there are no externalities on non-traders. With private offers, we get what, from the standpoint of the vertical structure, is inefficient in the sense that we don't maximize joint profit, we get duopoly profits instead. Okay, in the case of private offers. So, and coming to the question we started with a few minutes ago, of course, this is saying it's worse for bad for the industry that we have private offers. Of course, it's good for consumers Consumers here get lower prices when we have private offers than when we have public offers because the competition, the externalities between the retailers come into play. Okay? Questions?
So, is there a policy aspect to this? I mean, when regulators look at the industries, there a sense in which private versus public offers matter in the policy?
Can you repeat?
Yeah, the question is, sorry, the question is, does it, in policy debates, does it matter whether it's public or private offers? Does this come into play? It doesn't come into play in, well, I guess I would say this, yes and no. Always hedge your bets, an economist. No, in this sense that like, okay, well, let's do the yes. Yes, in the sense like, okay, if you had some antitrust case, it might not surprise you that like the defense might write down like some model that has one assumption and the plaintiffs the opposite because it matters. Okay, so for example, this model will end up getting used for questions of is there an impact of vertical integration? So like if you think about this Cournot retailer model, in the case where if the manufacturer merged with the retailer, okay, now since the retailers were assumed to be homogeneous sellers of this output, the vertically integrated firm would just never sell to the other retailer, right? But you would get a monopoly outcome for the industry, and consumers would face the monopoly price, but they would face the monopoly price with public offers either way. But with private offers, they would face a lower price without vertical integration, which is this outcome, than after vertical integration. So it would matter. Okay? So you can imagine, like in a case, people might pick different offers, but I've never seen something where like people start debating our offer, like, oh, do we see in the in the documents that like it's public offers or private offers? Maybe Ali.
It came up in 18
Okay.
forget what
Like literally where they're talking. So who was it? Who was in the expert or?
what side was trying to make what point, but it came up in the judge liked was the idea that people move around from firm to firm, so the contracts last like 5 years, so sort of working assumption was everybody knows everything.
Yeah. So I guess the question though is like,
Reporting what happened.
right. So who is it who? Actually, you're saying that the testimony of the executives was like people move around, and the judge made some. Was it an expert or a judge who then said, therefore, we should use a public offer model?
I don't remember what steps they took because of that, but
Okay. It was relevant. Okay.
So, just to add or maybe to ask also that isn't depend on the objective of the policy, that if a policy itself is like oriented to the say making firms better off or maybe to increase their revenues, then maybe we should use the public, and if the objective is to make the consumers better off, as
Yes.
you said, so then it just depends on the objective of the policy itself. That
No, I think we're clearly saying that it's not that private offers or public offers would be better. I think the question was, if you were thinking about policy, like, would it be relevant? Would people start talking about? And prior to Ali just a moment ago, and I haven't read through all the AT&T Time Warner stuff yet, but I was saying like I hadn't really seen that in like them debating it, but like you could well imagine like parties on different sides picking their models judiciously. And then, of course, the question would be, preempting Ariel's question, like, could the data start to tell you something about which was the right one? And in principle, the answer should be yes. And we'll talk a little about that. Okay. Okay. All right, so this Cournot result does generalize to non-constant returns to scale. And there are some cases where multilateral deviations, let me just close this so you're not listening to Multilateral deviation in some cases can matter as well. So, here I just use the necessary bilateral conditions, but sometimes the multilateral stuff matters. Okay. All right, let me just make a few remarks about this non-cooperative model with private offers. First is, there's this, in a lot of the literature, there's this assumption of passive beliefs. In some cases, passive beliefs is not a very reasonable assumption. So to take a really simple example, imagine we were in the Cournot retailer model, and the upstream firm, instead of having constant returns to scale, has a capacity of 10. And we're looking at a potential equilibrium where each party is supposed to get 4, okay, as a quantity. And imagine then the manufacturer comes to you and offers you 8. Okay, it's pretty clear that the manufacturer is not offering 4 anymore to the other firm. Okay, it's not trading 4 with the other firm because that exceeds its capacity. And so the more general point is, if there's non-constant, Hart and Tyrrell are very smart, and they judiciously, I think, picked in their model, picked the case of constant returns to scale because the trades are additive in the payoff function of the manufacturer. And so as a result, when the manufacturer deviates to you, the manufacturer's incentives to sell to the other firm don't change. But if you had, say, increasing returns to scale, so that marginal cost was increasing, when you were offered more, that should, at some level, the incentives of the manufacturer to sell to the other firm go down, right? Because his marginal cost is higher the more he trades with you. So you could start thinking about that.
For realism, if you were doing passive beliefs, wouldn't you want to know if it's incentive compatible to keep the beliefs passive?
So I mean,
You could-
incentive compatible in what sense?
That I'm the retailer, I don't want to tell anybody else.
No, so the question isn't about telling. The question is, not privateness, but passive. Like, if I come to you and make you an offer of 6 instead of 4, what do you think I did with Eric?
Yeah, that's true.
Okay, what do you think I'm doing with him? And so I gave you an example where passive beliefs, with capacity constraints clearly doesn't make sense. But more generally, this idea that if I have, let's say, increasing marginal cost, the more I offer you, that has implications for my incentives to trade with Eric, right? And now the thing is, so you start to say, okay, passive beliefs may not make sense. Maybe I should look at equilibria with any beliefs. Well, in that Cournot retailer model, the way we've done it so far, basically once you do that, anything can happen, okay? Basically what I can do, I can sustain any individually rational trades with all of you. And the way and the beliefs that which means you just earn, as long as you all earn positive profits in equilibrium, it's an equilibrium. And how do I sustain that? I sustain it by you having beliefs that if I ever offer you a deviating trade, it means I'm offering Eric 100 billion units for free. Okay, actually I'm paying him. Okay, so what do? You reject. You would reject paying any positive amount to me. So there are beliefs that keep me from deviating to you. And so we could sustain anything. So there have been different directions people have gone. Some people have tried to put reasonableness assumptions on beliefs. The notion of wary beliefs that McAfee and Schwartz looked at. A different approach, Ilya Siegel and I have this paper where what we show that there are, the way we've analyzed this model so far was with contracts in, say, in the Cournot retailer example, where basically either it's a point contract or I offer, a nonlinear schedule, but it's the retailer who gets to pick how much to trade. But if you switch it around and the manufacturer makes offers to the retailers that are menus that the manufacturer gets to decide how much to trade, that actually there are I'll say clever, not hard to roll cleverly, but cleverly nonetheless constructed contracts that make it so that the retailer would be willing to accept no matter what their beliefs are. And it's actually very close to the Maskin-Tirol work on principles with private information. So when I'm the manufacturer and I make you an offer, I know something about how much I'm trading with others, and you don't know it. And I can construct offers that in some sense screen myself about how much I'm trading with others. So anyway, that's a different, we won't go down that road, but yeah.
Say you're offering me 6 and the equilibrium is 4 to everybody.
Yeah.
Why can't I just ask the question, okay, so given that you're offering me 6, what is the optimal offer you're going to give to all the other players?
Right. The thing is, it sort of depends on their beliefs too.
So yeah, is this unsolvable?
As I said, McAfee and Schwartz have some wary belief idea where they try to kind of go down that road. We have this other approach I was just mentioning where, as I say, we identify that there are certain contracts you can offer that are accepted regardless of beliefs. So that when you do these menus, and that puts constraints on equilibrium. And for example, take an example. With passive beliefs in the Cournot retailer model, we did duopoly, but the answer if you had n retailers would be n-firm Cournot. And so there's a competitive limit result. As you have more and more retailers, actually the the price consumers pay approaches the competitive price. In the way we do things, using these kind of contracts is enough to imply a competitive limit. That you have in the limit, as you have more and more retailers, price has to go to the competitive level.
This is true despite there is a monopolist producer.
Correct. And it's coming from the fact that we have, private offers. So there are these private offers, and we can't fully control these externalities. It's a lot like, an analogy that Jean likes to use a lot is it's a lot like durable goods monopolist. Like the durable goods monopolist kind of undercuts himself by, he's going to, once he trades something today, he's going to trade more tomorrow. And the first buyer anticipates that and is not willing to pay very much. Here, the upstream monopolist is kind of undercutting himself. Like, given what he's trading with retailer 1, he has an incentive. What he'd like to do to get monopoly profits is commit to sell only to retailer 1 the monopoly quantity and get a payment equal to the monopoly revenue. That would be maximize the upstream firm's profit, the manufacturer's profit. But the problem is, once the retailer 1, if he does sign that contract with retailer 1, he then has an incentive to go sell to retailer 2 also. And they have their joint surplus from trading, given the monopoly quantity, is positive. In fact, what it is exactly the Cournot best response to the monopoly quantity of retailer 1.
One more thing, and there is no way to combine private and public at the same model.
Public? I don't know. No, I don't. So I don't know quite what that would mean, but I guess a little bit what I was suggesting earlier is like when we had this discussion of like how stylized it is, and I'm about to say 1 or 2 things about this, how stylized it is, that this model that like it's like the private assumption, like the fully private assumption where everyone simultaneously accepts or rejects, not knowing anything, seems very stylized and strong. And then, but when I guess when you start thinking, well, how would you make that more realistic? It's like, okay, what becomes observable when and how, so maybe there's a useful model to pursue. I think it's a good question, but I haven't seen anything that does this. Eric.
Just a small question. A moment ago you said the monopolist has the problem that if he offers a contract to party A, then he's going to undercut himself later by offering a contract to B. But would it be illegal for him to write into his contract with A, if I ever offer a contract with B, I will pay you a fortune?
Right. So I mean, a stronger version of that is to write an exclusive contract with retailer 1. You will be my only retailer.
Right.
And exclusive contracts under some circumstances are, illegal. This model that we just looked at would be one theoretical. There are a number of theoretical models for, why exclusives can be anti-competitive, but the one we just looked at is one, because an exclusive contract achieves just what vertical integration would achieve in this simple model. The two are do become different if downstream retailers are differentiated, but when they're homogeneous, you only need one retailer to maximize vertical structure profit. So, yeah.
And how restrictive is assumption about no externality on effective traders? So
On efficient.
efficient traders, yeah. So is it required to make equilibrium concept like tractable, or is it more?
So the no externalities on efficient traders was just for the result, is a sufficient condition to know that passive beliefs equilibria have to be efficient.
It's not. Efficient, not necessary.
Right. So you could potentially have a model where there's almost no trading options other than what's efficient, and then there's some miserable thing that nobody wants to do, right? So, okay. Second comment. There are, of course, many possible different bargaining games that we could do. This was the offer game. We just spent the whole time doing that. You could imagine a bidding game where instead the agents made offers to the principal. Okay, so and then the principal chooses simultaneously which offers to accept. When you all make offers to me, and I decide what to accept. So if you're thinking about the differences from the offer game with private offers, it's useful to kind of just think about the difference. So one is, the agents in a pure strategy equilibrium, they actually know what the offers are of the rivals. So in a pure strategy equilibrium, if you thought about it, there's an offer by each agent to the principal. And when agent one is thinking about, should I deviate in my offer to the principal, the agent in equilibrium knows what everyone else is doing. So this belief issue doesn't come up. Okay? So that's a good thing, because the beliefs had all this multiplicity and all the rest. And so it's kind of like we're assuming passive beliefs, right? That, assuming that you know what the rival's offer is and it doesn't change, and that you're thinking about when to deviate is kind of as if, getting you kind of the mileage just like passive beliefs did. A second thing is, deviations are just unilateral. In the offer game, the principal could make multilateral deviations. Here, an agent obviously can only change his offer. So that's a simplification. That simplifies things too. The thing that is more complicated is, one thing is that now when an agent deviates to the principal, it could induce change whether the principal accepts or rejects the rival's offer, for example. So that doesn't happen in this passive beliefs thing. In the passive beliefs thing, the principal has made his offers in the offer game, and the agent can accept or reject, but he can't induce deviations. Okay, and yeah, so that's a complication with when you start doing this bidding game, these bidding games, and it can potentially lead to significant complications. All right, and in general, bidding games turn out to be much harder to analyze and characterize what the equilibria are. And as I was kind of saying, alluded to before, if I started to go and have multiple agents and multiple principals, obviously the issues of bidding games show up, because now one side or the other, if you're doing simultaneous offers, is making offers like in a bidding game, where there are multiple parties, and you can make offers to someone, get them to reject the rival contract, for example. So there, that may be part of the reason why the non-cooperative literature, the theory literature, has kind of done a lot of, not everything, but a lot of the papers have been about this. In the monopoly retailer case, it turns out that it is fairly simple. But the monopoly retailer case was a case where externalities were very, very simple. And so it turns out that with a bidding game in the monopoly retailer case, there's an equilibrium that induces efficiency just like in the offer game. And what you do is each manufacturer makes an offer to the retailer, which is basically offering to reimburse for costs. It's a sellout contract plus a fixed fee. And the fixed fee is exactly manufacturer J's contribution to vertical structure profits. So this is, if those of you who know kind of the common agency literature, this kind of is like the common agency literature. The manufacturers are like the principals. The retailer is the common agent. Okay. What else did I want to say? Oh, one thing in the bidding game, let me just say that if you started to do the Cournot retailer model where there are externalities on traders, you end up, we've got, bidding games get rid of passive beliefs, but they can have a lot of multiplicity in other ways. That is, you can have if you start allowing fairly rich contracts, like the contract that I want, is there any chalk? Yeah, so, if I have like upstream manufacturer, retailer 1 and retailer 2, the trade between the manufacturer and the retailer that maximizes, that's optimal is going to depend on what the manufacturer, if we have non-constant returns to scale, on the contract that you've written with R2. And so you can get situations where you can sustain a wide range of equilibria because I can find a contract for here that justifies a contract over here that then justifies this, but then there's other contracts that also are fixed points. So so that's kind of another complication when you have a lot of it, when you have these externalities. Okay, let me move on. Here this M-to-N situation, on this slide just lists some examples. One I left out is something with a couple papers by Mihai Mania as well. But there are a lot of pretty, the results that aren't 1 on N, tend to be fairly special models. And so I think, part of it is a theory thing. It's like, can you get nice, clean results in these more general models? It's has been difficult, I would say. So I should just say one other thing. In this Cournot retailer thing, I said there's multiplicity. At least in that paper with Ilya Siegel, we actually, for a Cournot retailer model, we do compare the offer game with general menu contracts and the bidding game, to see exactly what the correspondence is between these equilibria, and they do differ. There's multiplicity in both, and they do differ. Okay, so
is it for the offer game or the bidding game? This MN supplies you what? So this.
Well, when it's M on N, it's both. The offer and bidding terminology is really about 1 on N or 1 on M, right? So it's whether the offer game is the one is making the offer, the bidding game is the other way around. When you have M on N, in some sense, it's always like a bidding game, right? Except even more complicated because there now are multiple parties on the other side. You're all simultaneous making. One side is simultaneously making bids, but to many parties on the other side.
So it means is it MN offer game is equivalent to MN bidding game. That's what you are saying.
I guess I would stop using the terms bidding game and offer game then.
Just M.
Right. So. Right. And so I think I do want to just say that there's a distinction about whether people have made progress on the theory side and whether empirically you could make progress. Like, the necessary, it's clear kind of what the necessary conditions are, or what some necessary conditions are, even though it may be hard to characterize what the set of equilibria is. So you could potentially have inference even if you can't have some nice characterization result. But at the same time, I think some of the problems, difficulties in identifying equilibria in these bidding games are sort of suggestive that there could be a lot of multiplicity and other things that come up in these general contexts if you do non-cooperative things non-cooperatively. Take a non-cooperative game theoretic approach. Okay.
Multiplicity, you can sometimes tell which equilibrium it is from the data. So, it's multiplicity, and you look at the first order.
Yeah.
Can you repeat the question?
Oh, could I repeat the question? I didn't know who you were asking. Okay. Ariel was saying that empirically you can, sometimes tell which, maybe you should, which equilibrium it is. Right. Right. Yeah, I guess. Yeah, so I haven't seen anything that does this. So I'm sitting here trying to think like, okay, exactly, in which settings would you potentially actually, would you potentially be, what would the first order conditions be? And then you will see when we look at the empirical work, in some of this empirical work you observe what the contracts are. In other settings you don't observe what the contracts are. I'm not sure in which case you meant. Probably the observability case would be my guess. But yeah. So, we're going to see this. Hopefully I'll have time to talk about this one paper. There's one paper that tries to do a non-cooperative approach to empirically. I think the jury is still out on to what extent the theory in non-cooperative theory game theoretic models will be useful pushing forward empirically. I think what I'm about to talk about, this Nash-in-Nash bargaining approach, has been what the literature has tended to do. I'll have a few comments on why maybe aspects of what people have done that make it seem easier and more successful than maybe, when you start to write down the game theoretic model, the things that can make it very complicated are things that are often assumed away when we do Nash-in-Nash. So I'll say something about that. So let me talk about Nash-in-Nash. I started at 3:30 and go to 5, is that right? No, do I go to 5:30? I started at 4 and I'm going to 5:30. I can relax. Okay. All right. So I guess before we start on Nash-in-Nash, I guess I would sum up the game theoretic non-cooperative theory literature by saying there are some very nice clean results. The models are, the downside is that the models are, even for those clean results, in some cases fairly stylized, like in this case that we were talking about of private offers. And B, like the offer game has very nice results. Bidding games in many settings or other more complicated bargaining processes, harder to get nice results. Okay, so that's kind of how I would summarize it. So I think there is hopefully progress to come, but remains to be seen. Okay. All right, so let's talk about Nash-in-Nash bargaining. So before, we started bilateral contracting, and I mentioned two approaches. One was non-cooperative, bargaining, take it or leave it offers. The other was Nash bargaining, maximize the Nash product. We then said, okay, in reality, we're almost always in settings with many agents, many parties, not just two. And we went down the non-cooperative road. So now what I want to do is go instead down the Nash bargaining road with multiple parties. Okay. So let's consider a case with M principals and N agents. Principal J, utility is UP of J, which depends on, I'm now writing this with somewhat different notation, but the full set of trades between different pairs I and J. And agent I's payoff is UI of A with, again, depends on the full vector of trades. And we have, okay. So the definition of a Nash-in-Nash equilibrium is that each pair the trade for each pair maximizes their Nash product given the trades of everyone else, every other pair. Okay? So that's all this is saying. So the vector of pairs, x hat ij, is Nash-in-Nash if each x hat ij maximizes the Nash product where we take as given what every other pair, which I'll call x hat minus ij, is doing.
So the scalar inside J is just what I...
It could be a scalar. I mean, again, just like our notation before, you could have a broader interpretation. It could be incentive contracts. It could be other things. But often when we get to the empirical literature, it's going to be a price, a linear per unit price. But in the empirical literature. But in principle, it can...
Price between I and J.
Yes. Okay? So if it's hospitals and insurance companies, it's the price per, actually, diagnostic DRG, that that the insurance plan J is paying to hospital I, say. Okay? But, more generally, conceptually, it could be a much broader thing. Okay? Yeah. Should turn to my Nash-in-Nash expert. So Grennan, it's a per unit price. Our paper, it's a per unit price. I think are there cases where it's richer than a per unit price? Nash-in-Nash? Asking you. Okay, yeah. The what? Bricks. I don't know the paper in one. Okay. All right. Okay. So almost, I'd say, I've never seen the Bricks paper. Or who it's by or anything. But the papers that I know, it's price. And I was going to come to this later, but let me just say, if you're assuming that's what a contract is, it would be like a non-cooperative approach would be much simpler. Like a lot of the problems that I was talking about would go away if the contract space was that simple in a non-cooperative model. Okay, so one of the things when we get to empirical implementations is that a lot of the things that, there are things that seem really, really simple in the empirical approach, but part of it is that the contract spaces in my view, that the contract spaces the papers have assumed are very, very restricted. And so multiplicity, is a much smaller problem. A lot of things are much simpler. Okay.
Once you have more flexible contracts, pretty robustly, you get them the wholesale prices equal to cost. We don't see that in reality.
Right. So maybe, maybe there's a moral hazard problem or other problems that are making contracts more complicated, right? Right. So Ali is giving you the institutional defense of the per unit price thing, which is either, on the one hand, more theoretical. There are two defenses in these. We're jumping ahead, but one is, that's what we actually see in contracts, simple per unit prices. We've been guilty of that justification. Another is, if you started to write richer contracts, you would end up getting that say it was a two-part tariff, the per unit price would, just like in our very first example of bilateral contracting, would be set equal to the upstream marginal cost. And we don't see that. We see positive margins. So obviously, that's not the right model. We should have and then the retreat is to the simple linear price. Although maybe it's for other reasons. Maybe there are moral hazard problems or asymmetric information that are explaining that. But the literature kind of hasn't gotten there.
Two questions. One is, you have an equilibrium with two controls. Equilibrium with one control
control have to satisfy this given the set of other controls? That's one question. The
Yes.
second question is, don't I need a condition that the interior of these things is positive?
That there is something that has positive gains from trade.
Otherwise,
Yes,
not gonna trade.
sure.
So there's, you might not get a few of these guys trading.
Yes. So, in our paper on vertical integration, part of what we're doing is saying, after integration, maybe I don't supply to the rival the rival satellite operator. So, so there are potential implications, necessary, some other conditions, but anyway,
And the thing with two controls.
yeah,
Wouldn't one control, say I fix the other control for everybody.
yeah.
This control would have, it's fixed at its equilibrium value. Wouldn't this control have to satisfy this condition? And from the point of view of estimation, that's the question. If you believe the equilibrium, which you might not.
I guess, I'm sitting here a little, and I have to say, slightly puzzled in my response, because my first my thought is, take this thing about price has to equal marginal cost. That comes from actually doing both responses, I think, like, change price and change the lump sum transfer. So I'm sitting here thinking like, okay, what's wrong with Ariel's argument? Maybe you get a local minimum when you just do one dimension, and even though it's necessary, it's not. I'm not sure. I'm not sure of the answer, but yeah, we're jumping ahead a lot, but yeah. So okay, so we have this Nash-in-Nash condition, which is now up here. This is actually up now. This is just a complete repeat of what we did before. This is the first order condition for each bilateral pair. If one dimension is a lump sum transfer, we end up getting joint profit surplus maximization in the other dimensions. The only difference from our earlier bilateral setting is, in here is everybody else's x hats. That's the only difference. So just to kind of look at this in a special case where we have n sellers and one buyer. And like I've said, this literature, empirical literature almost always does, let's take a look at this example when the trade is actually just a linear price. Okay? And the reason I'm doing this is just to kind of work through an example of what you would, of what this first order condition would look like. And when you look at the papers, you'll see conditions like this. Okay? So imagine we have n sellers and one buyer. Okay? Each seller's payoff is, and the buyer has some demand as a function of the, so each seller they're bargaining over the price that the buyer will pay per unit to each of the sellers. Seller J equals 1 to n. And the buyer, given the price vector P, which is a vector of P1 to Pn, the buyer has a demand function for buying from seller J, xj of P. Okay? So the profit of seller J, given the price he or she agrees to with the buyer, and everyone else's prices are just this, Pj minus Cj, xj of P. And the buyer profit, or indirect utility, but let's call it profit, is V of Pj, P minus J. Okay? Just the buyer's profit or indirect utility depends on the vector of prices that are agreed to. So now, what's our Nash-in-Nash first order condition? If we go apply that condition that we had on the previous slide, and here, actually before I used gamma, but now the bargaining parameter is beta. So beta J is the bargaining power of seller J. So it's beta J. In the numerator is the derivative of firm seller J's profit with respect to PJ. It's a single product sellers. So what is that? That's just the usual first order condition if you were doing, static Bertrand, pricing game. BLP with single product firms. Okay? The denominator is the total profit of firm J. That's the gain from trade. 1 minus beta J is the bargaining parameter for power for the buyer is the remaining within that relationship. The numerator is the derivative of the buyer's profit with respect to PJ. PJ is an input price. Hotelling's lemma, I thought you probably thought you would never have to hear that phrase again, but Hotelling's lemma, i.e. the envelope theorem, tells you that is just minus xj. Okay? And then the buyer's gain from trade with seller J is V of PJ P minus J minus V of facing an infinite price with seller J, P minus J. Okay? And these are just a couple of other ways that you might end up seeing this expression rewritten. One expresses things here with the learner index. Another is, PJ depends on is marginal cost plus a markup term, effectively. But, if you look at this, if beta J equaled 1, so the upstream, imagine all the beta J's were equal to 1, so that all the bargaining power was upstream in this Nash-in-Nash thing. What this would tell you is that this numerator has to equal 0. That's just static equilibrium, the usual static manufacturer, upstream firms pick their prices simultaneously. Okay? We would basically have this, n equations of this first order condition for each of the j equals 1 to n. And the equilibrium would just be the usual static Bertrand-Nash differentiated product equilibrium. Okay? On the other hand, if these beta j's approach 0, this term is always positive, so what's going to have to happen is the denominator here is going to blow up, has to blow up, has to go to 0, so that this term, so that beta j is going to 0, so this whole term, though, can't go to 0. The way you do that is by having the denominator go to 0. What does that mean? PJ approaches cost. So if there's all the bargaining power is downstream with the buyer, the equilibrium in the limit is going to prices equal marginal cost. Okay? But for all the sellers. That's just what this is saying here. Okay? Just as an example of Nash-in-Nash. So let me just make a few comments about this Nash-in-Nash stuff. We'll be using it a lot in the next day or so. Okay, so one is what's its relationship to the non-cooperative approach? All right. So let's imagine that one side has all the bargaining power, kind of like what we were just doing in the case of setting beta j equal to 1. When that's the case, it's really the same as looking at a game with take it or leave it offers by one side of the market, simultaneous offers, and effectively passive beliefs over rivals contracts. So, this thing I said, it's a moment ago where we have n sellers and all the bargaining power is upstream, I said, it's the same as static equilibrium. Well, static equilibrium is kind of like a passive beliefs equilibrium. It's like you're holding, you're the seller, you're making offers, and you as the seller are taking as given what everyone's getting offered, and actually every buyer is taking as given what everyone is being offered. All the other buyers are being offered. And it's like that non-cooperative thing, except it's imposing unilateral deviations. So when you do Nash-in-Nash, you're doing each pair one at a time. And so if you have a seller that is selling to several buyers, you're only thinking about deviations one at a time and not simultaneous. And you're also assuming that a deviation can't induce rejection. So when you're taking as given what the offer is for everybody else, you're assuming that if I change my offer to Ariel, it's not going to make him reject a different seller's offer. Now, in the case where offers are linear prices, Ariel would never want to reject. Like, why would you reject an offer that just allows you to buy at a price? But if we were in a richer contract space where the offer, say, was a 2-part tariff, and he had to, by accepting, he had to pay a lump sum, in order to get access to that price, I could make him an offer that might lead him to reject that offer. But in Nash-in-Nash, if we did it with two-part tariffs, that wouldn't happen. We wouldn't be considering that. Okay. Couple of further things related to this. So Robin has a paper that for intermediate, this was kind of just having you think through the case of Nash-in-Nash where all the bargaining power was on one side, buyers or sellers. For intermediate bargaining powers, Robin has a paper with co-authors that generates the Nash-in-Nash outcome when the only negotiated term is a lump sum transfer. You can, if you want, you can talk to him about that. And this is just kind of a comment, the same kind of comment I was making before, that when I jumped ahead a little bit, which is, you know, when we look at the empirical stuff, the Nash-in-Nash stuff, like it seems like it's really doable. It's like simple, and some of that is, you know, okay, we are only looking at unilateral deviations. We're not worrying about rejection, which wouldn't be an issue with the linear prices to begin with, but we're not. But also, I think part of it, as I was saying before, is, you know, things would get potentially much more complicated in richer contracting spaces or, you know, richer contracting environments. You know, we might have multiplicity, we might have other issues that haven't really come up in a big way so far. Okay. A second thing, you know, the Nash-in-Nash thing has been used a lot. Makes a lot of sense in some settings, but there are some settings where it doesn't. And a really simple example of this would be, you know, imagine, let's switch this around. Wow, that is. My hand worked a lot better and didn't sound nearly as bad. Okay, so imagine we have two sellers and a buyer, and suppose there's a fixed cost of each seller selling to this buyer, or of the buyer buying from each seller. And that those fixed costs mean that in equilibrium, only one supplier, there should only be one supplier for the buyer, because otherwise you're duplicating fixed costs. And take a case where, like, the two sellers are actually selling homogeneous product. There's just a fixed cost. So you don't want to have two guys selling to you, okay? It would be inefficient. Nash-in-Nash, so in equilibrium, what would be a Nash-in-Nash equilibrium here would be, suppose bargaining powers were equal, they would split the surplus between them 50-50, okay? Why? Because taking as given that you aren't trading with the other guy, you're doing that, you know, you're splitting the incremental surplus of a deal, okay? But it's pretty clear, like in this setting, you know, if these are homogeneous products, we actually think like the buyer is going to get everything, because the buyer is going to play these guys off against each other. And Nash-in-Nash sort of isn't allowing them to do that, okay? So Robin has a paper with Kate Ho, and Sohail Gili also has another paper that is trying to kind of propose either an extension, let's call it, or an amendment, an equilibrium concept that allows you to kind of get at this. And it's important in certain applied problems. So, for example, in health insurance, you often hear, and I kind of alluded to this in the beginning, the benefits of having a narrow network. Like, I'm not going to have all the hospitals in town in my network. Why? Because then I can play hospitals off against each other about who is in my network. Okay, Nash-in-Nash, for the reason we just said, not so good at getting at the benefits of that. So it's kind of clear you're going to need something else. This already kind of leads to the third point, which is, you think like, okay, a different way of thinking about this is to say, well, about how the buyer can play these guys off is to say, well, what's the disagreement point for the buyer of not reaching a deal with S1? Well, he can go and trade with S2. And so you start, when you start saying that, you start thinking to yourself, okay, what is the right way to kind of model disagreement points? Like up to now, we've said if you disagree, you kind of basically don't have a deal. Your trades with everybody else stay the same. You just have a disagreement here. So that kind of leads to questions about dynamics and whether when we think about the disagreement points in this Nash-in-Nash bargaining, looking at the Nash product, maybe in the disagreement points you want to think about, basically the possibility that 10 minutes later I could start bargaining with someone else if I don't reach a deal with you. And so again, Robin has a paper in this case with Kina Fong that's kind of starting to, try to make progress on putting this into kind of a dynamic Markov perfect environment and to think about what the disagreement points should be in kind of a dynamic setting. Okay.
So there's some wedge between this literature and exclusive use?
Some wedge. So.
Yeah, so if I wanted to analyze...
Yeah, so the literature on exclusive dealing has been non-cooperative, right? So people haven't been doing Nash-in-Nash, and this would be a reason, so. Yeah. Oh, I thought you raised your hand.
You said you have a paper with Nash-in-Nash.
What, you mean the... We actually, yeah, but we don't quite do Nash-in-Nash when we're talking about the deviation. So, yeah.
Why don't you put Nash-in-Nash?
Well, okay, hold on. No, actually, I wouldn't say that. Okay, I would have to. So, okay, we're jumping way ahead because Robin is going to do this, and then I can heckle too. So, okay, so the paper Robin will talk about is I think, and that Ali's referring to, is a paper on vertical integration. Okay, so we have cable operator. We've got Dish, which is a satellite provider. We have DirecTV, which is another satellite provider. And we have a regional sports network. Okay. And when there's no vertical integration, basically the RSN is trading with all of these guys, and we do Nash-in-Nash. Okay? Then the question is, what if these guys merge? Okay? And the question then is, what about, will the merged firm trade with the supply the satellites? Okay. The thing I was saying to Ali, we don't really quite do Nash-in-Nash actually wasn't really an answer to his question. That's really kind of because we have these two separate guys. So let's simplify the setting and suppose we did this. Then it's really bilateral bargaining, right? Like if we didn't have two guys, it would be bilateral bargaining. And so it's not really Nash-in-Nash at that point. It's just a bilateral trade, right? So that's why I didn't. That's why I stand by my answer. But we can wrestle it out later. So, okay. What do I do? Excellent. Okay, we have 20 minutes to get started here. Okay, so I have 20 minutes now and 45 minutes tomorrow. Okay, so I'm going to be able to do both. I'm going to talk about two empirical papers. Okay, one is a paper by Sophia Villas-Boas, and the other is a paper by Kate Ho.
There we go.
Okay. All right. Okay. I'm going to come to your lectures. I would come to them anyway. I won't heckle. I'm not a heckler. But, okay. It's okay. It gets much worse when we're actually not in front of other people. No, it actually doesn't. Insular. Here we go. All right. So 2 papers. So what kind of questions? This is really, in a way, a repeat with a little more detail about what some of the motivations are in these empirical papers. So there'll be some, actually, in particular, Sophia's paper, which is really about, like, okay, what contracting model best fits the data? And there are going to be an array of different models getting compared. In some sense, many of the other papers also are that, but in a kind of more limited sense that maybe we're within the Nash-in-Nash framework, but we're estimating bargaining powers. So you could say, like, okay, that estimation of bargaining powers is asking which contracting model fits best, but it's going to be kind of within a class of Nash-in-Nash models. So Sophia's paper is like very much, okay, just like which contracting model fits the data best. The other papers, they're using, it's implicit that they're estimating to some degree, like in this bargaining power sense, what bargaining power matches the data. But they're all kind of, to some extent, more looking at some applied question. They're using, the model is there, but there's a kind of a applied question that's being looked at. So, for example, to the extent, Kate Ho's question in some sense is what are insurers paying different types of hospitals? That's kind of like if you were saying what's the applied bottom line of her paper, it would be about that. Viv Nevo has a paper, joint paper with Gautam Garashankaran and Bob Town, that's about looking at, what's the effect of 2 local hospitals merging. And it's in a setting, on prices that they charge insurers. And part of that is going to be a model of Nash-in-Nash vertical contracting between the hospitals and the insurers. Ali has a paper with Greg Crawford looking at what's the effect if instead of having cable operators charge, sell bundles, like you have to sign up for the whole bundle of channels, what if they had to do some form of a la carte pricing where, you could buy channels separately or, smaller bundles of channels. And part of that is, the key thing in that paper is, well, if you do that, it's going to have effects on the prices that channels can bargain for with downstream distributors. Once you consider that, what's the overall effect on consumers? Okay, and then our paper, which we were just talking about, is about vertical integration. So it's about what if regional sports networks are vertically integrated with cable operators. For one thing, how much double marginalization do we think it would eliminate? Are there efficiencies from that? And on the other hand, will they stop supplying or supply only at higher prices to satellite providers that they compete with after vertical integration? Okay. So let me talk about Sophia's paper, and we may get through it or may not quite get through it today. Okay, so Sophia's paper is looking at, it's a classic I/O example of an incredibly important market that we I/O economists tend to look at. It's yogurt. I'm sure for the rest of your careers, your applied micro colleagues will just be giving you constant shit about this. Just get used to it.
Well, it's complement to cereal. So we're analyzing cereal. We must also analyze yogurt.
Right. They will, okay. All right. This is a road I won't go down. All right. So the key thing here is she's she doesn't know anything about the contracts signed between manufacturers and retailers, but she wants to know, maybe the contracts that are the form of contracting process is important for the final prices consumers pay, and what model, like if we don't see that, the actual contracts, can we still infer something about how the contracting process works? And just to make clear, one extreme in this, and the way this literature, the way this would have typically been done before this paper is in the breakfast cereal mode or the BLP mode, that the manufacturers simultaneously pick prices, and that determines, and they're the ones picking effectively the retail prices consumers are paying. So in effect, it would basically treat the stores as if they're just perfectly competitive and just, add their cost, if any, to the prices. Okay, it'd be equivalent to that. And that's going to be one of the models that she considers, but not the only one. Okay. So we have a number of different yogurt manufacturers. In her situation, she's going to be she has data from 3 supermarkets in a certain large Midwestern city that was very close to where I lived for a while. And they sell to consumers. And the stores are differentiated. So, it's a setting where, when she looks at demand, consumers are going to care about the kind of yogurt they buy. So they're going to like Dannon yogurt, maybe they like Yoplait, maybe they like cherry or apricot flavors, but they also like to go to the store that's near them or that they happen to like in other ways. Okay? Okay, so as I said, she observes, so what does she observe? She observes retail prices, the final outcome of this process, but she doesn't observe wholesale contracts or the contracting process. She also doesn't observe wholesale or retail marginal cost, or by wholesale I mean manufacturer, but she does observe input costs. So she knows, like, okay, cherry extract costs this much, milk or whatever, plastic that goes into the cartons. She knows things about those input costs. Okay, so how does she start? She starts in the, classic way that IO papers now, have proceeded now for some time. She starts by estimating demand. And as I said, okay, it's going to be a random coefficients, discrete choice model, BLP style, but where a product is, the particular product, Yoplait, Dannon cherry yogurt, but comma, what store it's at. Okay? And then the input prices interacted with product dummies are used as instruments. Okay? All right, so she estimates demand, and then given demand, what she does is an assumption that retailers have constant marginal cost. She derives the conditions on margins that hold for several different models of vertical contracting. And it allows her to basically back out implied marginal costs. So the different models that she considers, there's a double marginalization model, which is kind of the M on N version, which is upstream manufacturers first pick their prices, the wholesale prices, then downstream retailers, the 3 retailers, simultaneously pick the retail prices that they're charging for all the different products. Okay? Yeah?
So just to make sure, those are local supermarkets, and
Yeah.
you're assuming they're negotiating directly with Yoplait?
Well, so this is a model, it's not going to be Nash-in-Nash, okay? So it was sort of the first paper that started to try to say, can we infer something about the contracting process from when we don't see the actual contracts or the prices? And you'll see what it's going to be is a number of kind of extreme models, that all lead to a certain kind of structure on the first order condition, but it's not going to be Nash-in-Nash.
So posted price, if it turns out that they're just buying according to fixed wholesale prices from Yoplait, then we're checking for that also.
Yeah, so double marginalization, what is the non-cooperative model? we pick linear per unit wholesale prices by the manufacturers simultaneously. Downstream retailers see the full vector of prices, wholesale prices. They then pick retail prices per unit simultaneously. Demand is realized. That demand then determines, of course, how much they're paying the upstream manufacturers according to those wholesale prices. So that would be the double marginalization model. Another model is marginal cost pricing by manufacturers. Manufacturers basically charge price equal to marginal cost, and then retailers take those marginal costs. That's their input prices, and they simultaneously pick prices. The reverse is retailers just, price at wholesale price. Manufacturers picks wholesale price. Retailers set price equal to wholesale price plus marginal cost, retail marginal cost. That's basically the equivalent of like BLP, where you just the retail sector never appears. Effectively, the retail sector never appears. It's just upstream firms that are strategic in picking their prices. And then there's a joint monopoly model where maximize vertical structure profits, and there's a couple of other models. Okay, and what she does basically, I'm going to show you in a minute, that these models kind of lead to a certain form for first order condition for for retail prices, and you can think of what she's doing a couple different ways. One is that she's kind of inferring what marginal costs are and then seeing which model implies marginal costs that fit the movements of input prices the best. Another thing that you could think she's doing is something actually just like what Ariel said earlier today, which is regress price on these input prices and the implied markup, and which one generates like a value closest to 1. That would be kind of similar.
BLT isn't an equilibrium model. It's a demand system. You had the Nash system.
Yes. So really, I guess I mean Aviv.
BLT and Nash.
Yeah, or Aviv's paper,
Yeah,
say,
that's
right? Which is, yes. Okay. All right, so let me just give you an example of how this first order condition comes. So each model is going to turn out to have a form which is price minus the sum of the marginal cost of retail and wholesale being manufacturers, equals some markup term. And the models are going to differ in what this markup term is. Okay? So let me show you for the double marginalization model what that would be, just as one example. So what the retailer does is retailer R solves the problem of picking. Retailer R is a multi-product firm. It has a set of products, SRT, in period T. Retailer R is selling these products in set SRT and is maximizing the sum of its profits, picking its price PJT for each of those products, and its marginal cost for product J is the wholesale price that it's facing, that's been determined already upstream by the upstream manufacturers. Is there a jet engine, like jet about to come through our room? And its retail marginal cost of selling product J. And SJ are the quantities or shares, given the retail price vector P. So we get a first order condition, standard looking first order condition, for each product, let's say K element of SRT. It's just the share of product K plus the sum of the impacts of, changes when you change the price of product K, retail price, it changes the retail sales of each product that retailer sells, and these are the margins. Okay, so that's the first order condition. And you can write it in a very compact way, kind of a stacked first order condition for all of these firms. And so you have all the products in the market. This is a vector of the quantities or shares of all the products in the market. And here's the vector of margins for each of these products. And this thing is basically a matrix which has retail substitution and it multiplied by ownership. So, oh God, it's hopeless now. Which is the better one to erase? It's all right. Here we go. I'll use my other hand. I need an eraser.
Maybe,
I got it.
oh, I think there's a better one here. This may not be better, but it's different.
Oh, it is better, Eric. Thank you. I'm good.
Oh,
This is, yeah,
does work.
this is excellent. Hold on a second.
Well, here's another one. Another choice.
Okay. This one's really nice. Okay. All right, so this matrix basically is the change in the share or quantity of product 1 with respect to product 1's price, the share of product 2 with respect to product 1's price, share of product 3, let's say product, suppose there are capital N products in the market, product 1's price. But we're now going to multiply, have zeros or ones depending on whether these products are jointly owned. So if product 1 and 2 are jointly owned, we're going to multiply this times 1 and this times 1, but all the others by 0. So they zero out. And when you do that, that's just going to generate these kind of first order conditions. Okay, so we get that stacked first order condition. And then we're going to look upstream. The upstream manufacturer has a set of products. Manufacturer M has a set of products that it sells. Maybe Prince William is taking off. I don't know. This is the margin on product J. And here are the quantities of product J that are sold. And the quantities of product J that are sold, P, T is a time subscript. P is a vector of retail prices, and it's a function of the vector of wholesale prices. Okay? So basically, upstream firms pick prices, and then downstream firms, given those prices, have a static simultaneous pricing equilibrium. And this is the equilibrium function. Okay? So that's this manufacturer's picking, I didn't put in what it's maximizing over, but it's maximizing over these over the vector P of wholesale prices for manufacturer M. Okay? We get a first order condition, same kind of first order condition. This is the quantity of product K that manufacturer M sells, say Dannon cherry yogurt. These are the margins of all of Dannon's products. And this is the change in the retail sales as a function of the wholesale price of product K that Dannon charges, say Dannon cherry yogurt. And so this includes retail pass-through. This is a reduced form. Given the price of Dannon cherry yogurt, how do all the prices downstream a change in that changes all downstream prices and therefore changes all downstream quantities. Okay? And now the thing that's really convenient is, given an assumption of constant marginal cost, this pass-through thing is only a function of demand. If marginal cost wasn't constant, it would depend on more than that. But here, given what she assumes, she can just get that off of demand.
Is that a reasonable assumption?
I'm not in the yogurt business. I don't know. But I'm just telling you what makes things fly. Okay? Okay, so you can do the same stacking thing. It looks kind of similar. Here we have a manufacturer ownership matrix, and we have a demand response matrix, but that is these demand responses, not the ones we had before. And we get this form. We add up the two set of stacked conditions, and we get this condition that price minus retail cost minus wholesale cost, marginal cost. That vector has to equal a vector of markup terms. Okay, and then if we know the retail price, we know the shares. We know that the ownership matrices, and we've estimated effectively these response terms. So basically from that, we can infer back what marginal cost, the sum of marginal cost is, retail plus wholesale. Okay? And then, as I said, the exercise is going to be to basically, one way of viewing it is, regress for each, you're going to get something like this for each model. So for each model, we're going to infer something about what the sum of costs is. And we then are going to see which fits the input price movements the best. Okay, let me skip over that. Let me see. One. Okay. I'm going to, let me, we okay 5 minutes? Or are you guys done? Hmm?
Yeah.
You're okay?
Take 5 minutes. It's the first day. They've got lots of energy.
Okay. The good thing about that is I can be done with this paper and I don't have to remind you of where we were. Okay? Okay. So, you know, what is it? It's worth just saying, like, what is it that identifies the difference between these models? So just to take a couple of examples, you know, suppose we wanted to think, well, what's the difference? I don't see the contracting process, you know, or the price what the wholesale prices are. But like, what is it that lets me infer whether I have, you know, one model versus another, aside from just like the technical thing of like regressing costs on things. So, you know, let's take an example, which would be of comparing two models, a double marginalization model and a joint monopoly model. And let's think about it go back to the very beginning of class of today, where we had successive monopoly model, an upstream monopolist and a downstream retailer. And let's just ask, you know, what is it in the data that could possibly let us infer whether we have double marginalization is the right model, or they actually do manage to internalize the externalities and do the joint monopoly thing. Okay? So if you think about it, you know, earlier I said that you know, let's think about let's think about joint monopoly. Okay? So if this was a joint monopoly, say they were vertically integrated, what they would do is the monopoly thing. And the monopoly thing sets marginal revenue equal to marginal cost. So what you would do if you were acting efficiently, you know, if you had we estimate demand, so we know what the marginal revenue curve is effectively for the product. And what they should do is set a quantity that equates that marginal revenue to the marginal cost. Now, we don't know what the marginal cost is, but imagine there are shifts in demand that shift the marginal revenue curve for, you know, down the retail marginal revenue curve. Okay? And in particular, that rotate it. Okay? So that rotation, if you're maximizing joint profit, shouldn't change quantity. Okay? But if you have the double marginalization model, in general, it will. Okay? And earlier, at the beginning of class, I kind of drew this analogy in the double marginalization model to you know, perfect competition of the upstream firm. You know, the upstream firm might behave perfectly competitively, and that generates efficiency. Or it might behave in the double marginalization model like a monopolist. So those of you who have kind of seen like Bresnahan's like 1982 stuff on how do we identify perfect competition against monopoly? This thing is really the same thing. Because this thing, remember what I told you was that marginal revenue, retail marginal revenue, is upstream demand. So as I rotate retail marginal revenue, what I'm doing really is rotating upstream demand. And so, that would kind of just show you that in principle, these things are kind of identified. This difference is identified. Some of these other models, for example, you know, what if we aren't successive monopoly? We are thinking, say, about suppose we're thinking about joint monopoly versus, say, marginal cost pricing by the manufacturers. If we were thinking about that, there are, distinct implications. So, for example, imagine the cost of cherry extract goes down. Dannon cherry, producing Dannon cherry yogurt, the cost goes down. If the whole industry is acting as a monopolist, substitute product prices should go up, or probably will go up. Why? Because as a joint monopolist, if the cost of Dannon cherry yogurt goes down, the margin on it has gone up, and you want to shift consumers towards that product. How do you do it? You do it by raising prices on other products. On the other hand, if Dannon cherry yogurt and Yoplait cherry yogurt and Yoplait apricot yogurt are competing against each other, probably when Dannon cherry yogurt's price goes down, Yoplait's price will go down, not up. So they're going to be distinct comparative statics of these different models. So just to kind of give you an idea. Okay. She concludes the best model is marginal cost pricing by manufacturers, which you could think like it's what Elise says we don't see. Fixed charge plus marginal cost pricing. I think the strong part of this paper is kind of the idea of how you can identify things. I'm not sure that I can show you the tables and we could talk about it, but I'm not sure in the end it's like there's some funky things in the conclusions, and so the tables are here and I'm going to skip over them. Okay. I think the main thing I wanted you to kind of get from it is, like there's things in data, in principle, even when we don't see what's going on in this intermediate level, that could distinguish it. Now, when we look at applied papers, there are going to be some papers where we don't observe what's going on, and there's have intermediate prices, wholesale prices, and there are going to be some papers where we do. Of course, we feel better when we do, right? It's better. Data is better than assumptions. Okay. Okay. So this is the last slide. So if we think about Villas-Boas, she was kind of comparing these extreme contracting models. Tomorrow, we're going to start looking at bargaining environments. And they're going to be less extreme than Villas-Boas, but in some ways also more restrictive. So we're going to be, for example, in a lot of these, we're going to have intermediate bargaining powers, that's less restrictive, but maybe assume linear pricing, which is more restrictive. Okay? And we're going to use this vertical contracting framework not just to say what's the best vertical contracting model, but to try and answer some applied questions. So that's where we're going tomorrow. Okay, done.
Now we can.